I have mentioned that there are two ways to solve the inverse kinematic problem. One is the numerical approach and another one is the analytical approach. So in this session, I will be discussing on the various analytical approach. So there are two different analytical approaches. That is, one is a geometric approach and another one is the algebraic approach. So the objective is that we should get a closed form solution. Closed form solution is possible for any manipulator if at all it satisfies the condition that, say for example, if it is a 6 to manipulator, so your closed form solution is possible only if the three consecutive joint axes they intersect or they are parallel. So in most of the manipulators that are now manufactured in the industry, they do satisfy this condition so that we get a closed form solution. And while solving the inverse kinematic problem, we normally we do not use tangent function, that is tan inverse function. We use only a tan 2 function, that is inverse tan. A tan refers to inverse tan. So inverse tan 2 function we use. So tangent function, as you know, it is the opposite side by adjacent side. So if you have this tan theta, that is equal to y by x. So theta is equal to tan inverse y by x. So here in this case, as you see that it will give you the values only in the say supposing if it is in the second quadrant, as you see the angle, it would be the same in both the cases. So it will give you solution only in the first or the fourth quadrant. So we just go to prefer arc tangent 2 function. So instead of the tan 2 function, so you have two arguments. That is, you will be giving both the x and y functions, y functions. That is both arguments you'll be giving, so that you'll be return you'll be just getting the angle between minus pi to pi. So if it is tan function, it will just give in the between minus pi by 2 to pi by 2, whereas this arc tan 2 function, as we give two coordinates, that is both the coordinates we give, that is as shown in the earlier figure, it is both x and y we will be giving. So you will be getting the theta angle within minus pi to plus pi. So by examining the sign of both the values, that is x and y, the angle will be between this range. So it is always advisable to use the arc tan 2 function. Now, using the algebraic approach, how to determine the inverse kinematic, we will be just seeing the steps. So, first guideline is that the equation should involve at least one joint variable. So, first, if you just solve this joint variable, no, you will be the remaining joint variables will be solved correspondingly, and then you have to just look for the pair of set of equations. Okay, so then after getting the solution for one joint variable, you have to look for the pair of set of equations, so which can be reduced further by applying any algebraic or trigonometric identities, and you can just solve for another joint variable. So as I already mentioned, you have to always use the arc tan 2 function. So instead of arc cosine or arc sine functions, the arc cosine and arc sine functions are not always accurate. So that is why we prefer the arc tangent functions. And the third point is that, so supposing if you are having the transformation matrix 0t to n, instead of using the rotation information, it is always preferable that you use the position informations in order to solve the elements, right? So then the next guideline is, so you have to, so here as given here, this is unknown. The right side of what you have, it is known values, right? So this is the unknown value, that is you need to determine the joints. um, So here in this transformation matrix, you will have all the unknown values or the joint variables, and the right hand side of this equation that is known to you. So how do you solve it? Either you just pre-multiply the, say for example, first you pre-multiply with 0 t inverse, and then you can just get an equation with say n minus 1 unknowns. So q1 will be eliminated. So you will be getting n minus 1 unknowns, and then you can solve for the for solution q1, right? Or you can also do by post multiplying both sides by the inverse of tn to n minus 1. That can also be done. So this we call it as the inverse transform approach, and also this way of solving it is called the Piper technique.